One of the most effective bombers of the Second World War maintained a loss rate below 1% while being built almost entirely from spruce plywood and glue. This was not a primitive makeshift. It was a cold, aerodynamic calculation. How did glued timber withstand G-forces on par with duralumin? The answer lay in the seamless sandwich structure. Engineers abandoned the standard metal skin. Instead, they used a 3-layer composite. 2 skins of birch plywood housing a core of soft Ecuadorian balsa. This created a rigid, incredibly light shell. The assembly process mirrored high-end cabinetry. Workers laid thin wood veneers into massive concrete molds. They applied specialized urea formaldehyde glue. 2 halves of the fuselage took shape separately. Then, technicians joined them along the vertical center line. The result was a sensory anomaly in an age of rivets. Touching the fuselage revealed a surface as smooth as glass. No metal overlapping, no protruding bolt heads. This lack of rivets, standard on a Messerschmitt Bf 109, was the secret. It eliminated parasitic drag. Aerodynamic efficiency jumped by 15% compared to traditional metal construction. The manufacturing shifted from heavy industry to the civilian sector. Furniture factories and carpentry shops became aircraft plants. They required no specialized welding or heavy hydraulic presses. They used wood, clamps, and precision. At the peak of the war effort, the British supply chain achieved a staggering cadence. Every 24 hours, 1 complete Mosquito rolled off the assembly line. The logistical logic was cold. Metal had become a luxury Britain could no longer afford. Steel fences and kitchen pots disappeared into furnaces to feed the Spitfire lines. Every ton of aluminum was accounted for. Air Marshal Wilfred Freeman saw the dead end of the metal supply chain. He needed a shadow industry. Building a fuselage a day required a radical bypass of heavy manufacturing. The solution was wood. Specifically, Canadian birch for strength and Ecuadorian balsa for the core. This wasn't about tradition. It was about mobilizing thousands of idle hands. The strategy worked. While traditional factories buckled under metal shortages, de Havilland tapped into a hidden reserve. Piano makers and furniture craftsmen traded instruments for precision aircraft components. Master carpenters became aerospace engineers overnight. This maneuver bypassed the overburdened heavy industry sectors entirely. The skeptics remained loud. They ridiculed the wooden wonder as a regressive relic, but the project moved into the shadows to escape the bureaucracy. In a secluded country estate near London, the team began the secret assembly of the first prototype. The Mosquito squadrons recorded a loss rate of less than 1%. It was the lowest in the Royal Air Force. Traditional bombers relied on heavy steel turrets and layers of armor to survive. Geoffrey de Havilland rejected this entire doctrine. How could zero armor possibly protect a crew? Speed was the only variable that mattered. De Havilland stripped the airframe of every non-essential kilogram. He removed the heavy metal machine gun turrets and the gunners who manned them. Weight reduction generated raw velocity. Velocity replaced protection. The British government viewed the concept as a suicide mission. Officials refused to fund a wooden toy, while the industry struggled to produce enough metal Hurricanes and Spitfires. De Havilland ignored the rejection. He utilized his own factory and private capital to push the prototype forward. The Air Ministry remained silent. The government officially rejected the project. De Havilland's theoretical calculations faced their ultimate test on November 25, 1940. The wooden prototype stood on the tarmac. No guns, no armor, only 2 engines and a plywood skin. The first flight lasted 30 minutes. Telemetry data immediately silenced the skeptics. The aircraft moved with a lethal smoothness. How did a bomber outrun a frontline interceptor? The Spitfire Mark V was the pinnacle of British engineering. It reached speeds of 370 miles per hour. The Mosquito prototype exceeded this figure with ease. It left the metal fighter behind at every altitude. Air Ministry inspectors watched the instruments in disbelief. The smooth, polished plywood surface reduced drag to a theoretical minimum. They stopped calling it a flying coffin. The official reports now carried a different name, the Wooden Wonder. The Air Ministry reviewed the flight data and compared it to current requirements. Speed replaced the need for defensive turrets. The government approved the specification for immediate mass production. 3,000 horsepower, 2 wooden wings. One result, 400 miles per hour in level flight. Surpassing the Spitfire required more than polished plywood. It required the brute force of twin Rolls-Royce Merlin power plants. These engines transformed a timber frame into one of the fastest objects in the sky. The plywood airframe vibrated as the Merlins hit synchronized RPM. Why give a light aircraft a bomb bay designed for a 4,000-pound projectile? To deliver surgical strikes at speeds no anti-aircraft battery could track. The mechanics of the payload were a feat of spatial engineering. Ground crews maneuvered the massive 4,000-pound cookie blast bomb into a compact wooden cavity. This was the same ordnance carried by the heavy 4-engine Lancaster. The efficiency of the design created a radical shift in aerial warfare. A standard B-17 Flying Fortress required 4 engines and a crew of 10 to deliver a 4,000-pound load. It relied on 13 machine guns and massive formations for survival. The Mosquito performed the same task with 2 men and 2 motors. It traded tons of steel armor for pure kinetic energy. The Mosquito stripped away the defensive turrets to maximize the power-to-weight ratio. This transition from experimental engineering to tactical weapon changed the calculus of the air war. Squadrons began prepping the wooden bombers for high-stakes penetration missions deep into occupied territory. January 30th, 1943, 11 in the morning. Berlin prepared to celebrate 10 years of Nazi rule. The script was set, a radio broadcast to the entire Third Reich. Hermann Göring stepped toward the microphone at the main broadcasting house. He had once promised that no enemy bomber would ever reach the capital. He was wrong. Precisely at 1100 hours, the transmission cut. A trio of Mosquitoes screamed over the rooftops at low altitude. They didn't need a fleet of hundreds. 3 wooden planes were enough. The air raid sirens wailed. The sound bled into the live microphones, broadcasting the panic across Germany. 6 500-pound bombs impacted the target area. The Reichsmarshal's speech didn't start. It couldn't. Strategic bombers of the era were blunt instruments. 60% of their payloads missed the target entirely. The Mosquito was a scalpel. It put high explosives exactly where the intelligence officers pointed. Göring was not killed, but he was humiliated. He waited in a shelter while his reputation burned. The Wooden Wonder had turned the Luftwaffe's backyard into a playground. The embarrassment didn't end with the morning raid. By the afternoon, Joseph Goebbels prepared his own propaganda address. He expected the danger to be over. He was wrong again. A second wave of 3 Mosquitoes streaked across the Berlin sky, forcing the Minister of Propaganda to dive for cover as the explosions began. The psychological damage outweighed the craters. 6 uninvited aircraft had hijacked the most important Nazi anniversary of the decade. The group turned back toward England. German interceptors scrambled, but the wooden bombers were already gone. 5 aircraft returned to base. 1 was lost. Success over Berlin rested on an anomalous physical trait. The wooden bomber possessed the ability to outrun the latest Focke-Wulf 190 interceptors. How did a wooden bomber without defensive turrets survive during the day? The answer was fixed on the needles of German speedometers. The Luftwaffe relied on the Focke-Wulf 190. It was the butcher bird. Its heart was a massive BMW radial engine. This power plant gave German pilots unmatched speed over the skies of occupied France. At low altitudes, the 190 reached 650 kilometers per hour. It was a predator designed to tear Spitfires apart. Then came the Mosquito. The encounter was a clinical test of aerodynamics. German pilots sighted the wooden airframes and engaged. They expected a standard kill. Instead, the British pilots simply opened their throttles. The mechanics were lethal in their simplicity. The Mosquito lacked the drag of heavy turrets and thick armor plating. Its wooden skin was smooth. When the Merlin engines hit full boost, the aircraft converted every horsepower into pure forward vector. The gap between the hunter and the prey did not close. It expanded. Standard interception tactics became irrelevant. The Focke-Wulfs pushed their BMW engines to the thermal limit, but the wooden bombers left them behind. The German pursuit simply stopped. Speed allowed the Mosquito to dictate the terms of engagement. It was more than a retreat tactic. To exploit this, engineers integrated a massive battery of 4 20mm Hispano cannons into the nose. The design was a masterpiece of lethal density. 4 cannons sat in the belly. 4.303 Browning machine guns were packed directly above them. In a standard fighter like the Spitfire, wing-mounted guns required convergence. Pilots had to maintain a precise distance for the bullet streams to meet. The Mosquito eliminated this math. The nose was solid wood, no turrets, no heavy armor plating to protect the cockpit. Instead, the aircraft relied on a sharp, violent exit from the contact zone. How did this weight affect the wooden frame? The massive battery reduced the top speed by only 10 to 15 miles per hour. The aerodynamic cost was negligible. The tactical gain was absolute. During a raid, the airframe shuddered under the recoil. Pilots described the sensation as a fire hose shooting metal. It was a concentrated, linear stream of destruction. There were no blind spots in the ballistic vector. Every round traveled exactly where the nose pointed. This layout redefined low-altitude strikes. The Mosquito didn't need to dogfight like a Mustang. It hunted. It caught enemies during takeoff or landing, using the nose-mounted weight to shred airfields and ships in a single pass. The cannons delivered 1,000 shells per minute. The Brownings added another 4,000. Total output, 5,000 rounds per minute. Daylight was a death sentence. British High Command avoided it. Only the Americans accepted the price, losing hundreds of heavy bombers and thousands of young crews to German flak and interceptors. The math of daylight raids was simple: precision at the cost of annihilation. Why did the British avoid the sun? Statistics made daylight raids mathematically untenable for standard heavy machines. But the Mosquito broke the equation. It didn't need altitude, it needed the horizon. In 1942, the first bomber units began a lethal experiment. The doctrine: fly below radar, skim the treetops, strike with surgical precision. The wooden plane outperformed entire fleets of heavy bombers. In September 1942, 4 Mosquitoes crossed the North Sea. The target? The Gestapo headquarters in Oslo, Norway. Victoria Terrasse sat in a dense urban center. High-altitude bombing was impossible without massive civilian casualties. The Mosquitoes flew low. They hit the building directly, killing high-ranking German officials. 1 aircraft went down, 3 returned. It was the first time the public heard of the wooden wonder. The British press seized the moment. They gave the machine a new name: the Timber Terror. The wooden plane was no longer a secret. It was propaganda gold. Speed and wood had defeated the radar. The Timber Terror was real. Precision for the Norwegian strikes was born in the summer of 1941. The Mosquito Mark I did not carry bombs, it carried cameras. The first airframes reached operational status as high-altitude scouts. Engineers stripped the plane of everything: no guns, no armor, only fuel and optics. They applied a specific pigment, PRU blue. This deep, flat shade mirrored the tint of the upper atmosphere. From the ground, the wood and glue frame vanished against the stratospheric void. The machine stalked Nazi-occupied Europe from altitudes beyond the reach of interceptors. It mapped the continent. Every rail yard, every coastal battery, and every hidden bunker appeared on film. The Germans felt the shadow, but they could not see the source. These images became the blueprints for future devastation. If a shadow appeared on the horizon, the pilot simply pushed the throttles. The Merlin engines provided the only defense needed. At the first sign of a concentrated radar lock or an approaching interceptor, the Scout broke contact and raced back to base. Intelligence data from the Mark I Scouts revealed a new class of targets. The wooden airframe was no longer just a camera platform. It became a predator. The Tsetsi variant entered the theater. It carried the 57mm Mollins gun. This weapon began its life as the 6-pounder anti-tank gun. Adapting it for flight required a custom hydraulic recoil system to protect the light wooden fuselage. How do you destroy a submarine from the air? The Tsetsi solved this with direct hull penetration. A Mosquito spots a U-boat on the surface. The pilot pushes the nose down. He dives. One pull of the trigger. The 57mm shell leaves the barrel. The heavy recoil shakes the entire wooden frame. The steel hull of the submarine punctures like paper. The Luftwaffe faced a different nightmare at night. Mosquitoes transitioned to intruder missions. They did not hunt in the open sky. They waited. The wooden hunters hovered near German airfields. They watched for Junkers and Messerschmitts returning from sorties. The Germans lowered their gear. They flared for landing. At that exact moment of vulnerability, the Mosquito struck. The North Sea became a graveyard for German shipping. For anti-submarine work, the Mosquito carried 500-pound depth charges. For surface targets, it utilized sheer density of fire. Each wing housed massive destructive potential. 8 underwing rockets. The wooden frame, which would eventually force Germany into the era of jet aviation, first served as a high-altitude transport for a single human cargo. How do you smuggle a key nuclear physicist through enemy airspace? You lock him inside an unpressurized bomb bay. Niels Bohr carried theoretical data essential for the Manhattan Project. His survival dictated the pace of the Allied nuclear program. In the freezing dark of the compartment, Bohr sat among the racks. A metallic click signaled the failure of the oxygen valve. The mask went dead. At 30,000 feet, consciousness vanishes in seconds. Bohr slumped against the wooden ribs of the fuselage. Up in the cockpit, the pilot checked the intercom. No response. He looked back and saw the physicist motionless. The pilot shoved the control column forward. The Mosquito screamed into a steep dive, plummeting toward the dense, oxygen-rich air of the lower altitudes. Bohr regained consciousness as the pressure equalized. The mission continued. The airframe transitioned from a stealth transport to a precision scalpel. February 1944. Operation Jericho. The target was the Amiens prison in occupied France. Inside, hundreds of resistance fighters faced execution. 18 Mosquitoes flew at treetop level to evade radar. The weather was a wall of gray sleet. The first wave hit the outer masonry. Dust and stone erupted from the perimeter. The second wave targeted the guard barracks. High explosives shattered the walls while leaving the cell blocks intact. Onboard cameras captured the breach. Chaos filled the courtyard. Smoke rose over the rubble. 700 prisoners scrambled through the gaps in the stone. 2 aircraft failed to return, but the objective was met. 79 saved lives thanks to the precise strike of 18 wooden machines. Wooden architecture had clear chemical and logistical limits. Despite the success in Amiens, the Mosquito could not replace the entire British aerial fleet. Why did the British fail to make this aircraft their primary bomber? The answer lies in the Rolls-Royce Merlin engine supply chains. Every Mosquito required 2 of these power plants. The same engines went into Spitfire and P-51 Mustang fighters. They powered the heavy Lancaster bombers. This created a lethal logistical bottleneck. Production lines could not keep up with the demand. Doctrine also stood in the way. RAF Bomber Command remained fixated on massive 4-engined heavies. Their strategy relied on hauling maximum tonnage night after night. A twin-engined wooden frame did not fit this vision of total destruction. Geography exposed the final weakness. The airframe relied on specialized adhesives to hold the plywood together. In the heat of the Mediterranean or the humidity of the Pacific, the system failed. Glue joints dissolved, wood warped. The precision tool became a liability. The plywood airframe lost its structural integrity at temperatures exceeding 45 degrees Celsius. The same chemical vulnerabilities that melted British glue in the tropics became fatal for Kurt Tank and his Focke-Wulf 154. The Luftwaffe designer didn't just copy the concept, he stole the name. The Focke-Wulf 154 Mosquito was Germany's wooden mirror to the British original. It featured 2 engines and a plywood airframe. But the wood was only as strong as the bond holding it together. In 1943, Allied bombers leveled the Goldschmidt factory in Wuppertal. This plant was the sole producer of Tego film. It was a specialized phenolic resin. Without it, the German wooden aircraft program was paralyzed. Engineers scrambled for a solution. They introduced an inferior substitute. This acidic replacement literally ate the airframe. The smell was sharp and acrid. It dissolved the wood fibers from the inside out. The result was a catastrophe during a test flight. The prototype disintegrated in mid-air. The fuselage snapped. The test pilot died instantly. The Reich attempted other desperate measures. Mechanics fitted Messerschmitt 109s and Focke-Wulf 190 fighters with nitrous oxide injection systems. These GM-1 units provided short bursts of speed at high altitudes. Special night fighter units hunted the Mosquitoes across the dark skies of Europe. The Allies used wood to save aluminum and created masterpieces. The Germans turned to plywood out of desperation, but they lacked the chemistry to hold it together. By late 1944, the Luftwaffe command admitted defeat. They had no answer for the wooden insect. The project collapsed after the production of only 50 aircraft. Jet technology thrown into the hunt in mid-1944 would define the shape of all post-war aviation. While Kurt Tank failed with his wooden copy, the German High Command realized the piston era had hit a wall. To catch a Mosquito, you had to break the laws of physics that govern propellers. How do you intercept a target faster than your best fighters? You build the world's first turbojet engines. The physics of the kill were brutal. A standard German interceptor could only strike if it was already at a higher altitude. It needed a dive to gain a temporary speed advantage. The window for fire lasted seconds. Then, the Mosquito simply accelerated and vanished. Most losses came from flak. Ground-based anti-aircraft fire remained the primary threat because the Luftwaffe was too slow. Then came the shift. A high-frequency whistle began to tear through the air over Germany. This was the Jumo 004 engine. In mid-1944, the Me-262 and the rocket-powered Me-163 Comet entered the fray. For the first time, a German pilot could outrun the wooden wonder by a wide margin. But technology had a price. These machines were few. They could not be everywhere. Every jet sent to hunt a lone Mosquito was a jet missing from the defense of critical factories. The German command redirected their most advanced fighters from strategic defense to hunt the elusive wooden intruder. The jet age rendered the wooden airframe a relic of the past. High-speed friction and intense engine heat required heat-resistant metal alloys. Wood could not survive the physics of the next generation. How many of these machines left the assembly lines? Nearly 8,000 units. Production spanned a full decade from 1940 to 1950. It was a total mobilization of industry. Factories that once crafted high-end furniture and pianos shifted to war production. Craftsmen used their skills to glue wing spars instead of soundboards. They became the backbone of the British output. The Me-262 proved that metal and jet propulsion were the future. Yet the wooden Mosquito remained in service long after the world fell silent. It found one last war in the tropics. Pilots flew the final combat sortie over the Malayan Emergency. They hunted communist guerrilla targets deep within the thick jungle. The last mission ended in the Malayan jungle.